Hello and welcome to the Advanced Electronics and Energy Systems webinar. I'm Beth Rivera with FuzeHub. FuzeHub is a not-for-profit organization that connects New York small and mid-sized manufacturing companies to the resources, programs, and expertise they need for technology commercialization, innovation, and business growth. We help companies navigate New York's robust network of industry experts at manufacturing extension partnership centers, universities, economic development organizations, and other providers. FuzeHub is the statewide New York Manufacturing Extension Partnership Center and is supported by Empire State Development's Division of Science, Technology, and Innovation, also known as NYSTAR. Today, we're here to learn about the power of transatlantic supply chain connections in advanced electronics industries. We hope listeners will become engaged in an initiative to make B2B connections among clusters across Europe and North America, particularly New York State. In this fourth webinar of the series, we're hosting a discussion about advanced electronics applications in energy systems, an active area of technology development as the world seeks to satisfy increasing energy demand and reduce dependence on fossil fuels. You'll hear from New York State and European companies with leading energy innovations, as well as economic development organizations that are facilitating transatlantic advanced electronics B2B connections. Please stay tuned after the presentations. There will be a short Q&A session. Submit your questions at any time on the control panel in GoToWebinar, and we will address all of the questions that we can. I wanted to present to you all of the folks that are presenting in this webinar. Myself, Elizabeth Rivera with FuzeHub, Johan Lecoq with Silicon Europe Alliance, Lamar Hill with North America European Advanced Electronics Initiative, Don Durazo with Ionix Energy, Ralph Paul Schieferdecker with EA Systems Dresden, Antonio Aichetti with Rebus Tech, Jeroen Olde Dubelig with Bruco Integrated Circuits, Graham Hauser with Lux Semiconductors, and Bill Acker with New York Best. First, I introduced Johan Lecoq of Silicon Europe Alliance and Lamar Hill of Fusion Market Group and the North American European Advanced Electronics Initiative.
Good morning from my side. So my name is Johan Lecoq. I'm from DSB Valley, and DSB Valley is one of the founding clusters of the Silicon Europe Alliance. And the Silicon Europe Alliance is a collaboration of 12 European advanced electronics clusters. As such, I'm representing the European side of this cross-Atlantic collaboration, where we already I think it's now about 2 years are collaborating with organizations like New York Nanotech and FuzeHub. And based on this collaboration, we are able to offer you this kind of webinars where we offer the opportunity to both companies from the US side and the European side to present their technology to each other and to a cross-Atlantic audience.
Good morning, this is Lamar Hill. I'm from upstate New York. We represent the Northeast Advanced Electronics Cluster centered around upstate New York. And we've been partnering with Silicon Europe for many years now to foster, as Beth and Johan said, cross-Atlantic business-to-business connections. I just wanted to give a quick update this year. This is our fourth webinar. We also had a business-to-business connection workshop in Munich on Monday, November 11th at Infineon's global headquarters that many of you probably participated in. We've not put together this year's schedule yet, but within the next month or so, we will have a tentative schedule of our webinars and a couple live events that are that we're trying to connect more effectively companies to each other. So with that, I'll turn it back over to Beth and she can run through the speakers.
Thank you, Lamar. First up is Don Durazo of Ionix.
Hello. Sorry, it took me a little bit to unmute myself there.
Okay, go ahead.
Sure. I'm just waiting for the presentation to come up, but okay. Thanks. Well, good morning, good afternoon. My name is Durazo. I'm the founder of Ionix, and we're developing next generation electrolytes that lower the cost and size of energy storage systems. Next, please. This is just a quick overview of our company. As I mentioned, I'm the founder. I have a background in chemistry and physics. Our primary research lab is currently housed at Oak Ridge National Laboratory. We have access to the largest DOE prototyping facility in the country for energy storage systems. And we also have a collaborative partnership with SUNY Polytechnic, an academic research group housed there working on our second gen electrolyte. In terms of founding and funding, we were founded in 2014. We've received a series of federal and state grants, gone through a first generation prototyping cycle, and we expect to have a final product ready to scale at a contract chemical manufacturer in New York sometime late 2019, early 2020. Next slide, please. Oh. Well, before I talk about ultracapacitors, I'd like to discuss batteries for a little bit. So I think we're all familiar with how batteries can degrade over time. When you first pull out your iPhone fresh out of the box, it's fantastic. The battery has great longevity. But 6 months later, next slide, please, you start to notice that your battery has degraded substantially. You don't have the same lifetime. And next slide. This really just becomes your home screen for most of the time. So there's certainly an issue with present day battery chemistries. Next, please. So the question that we're seeing on the horizon in terms of market opportunity is, why are we taking the same lithium-ion battery technology that struggles to send text messages or help us surf the internet after 6 months, and then next slide, please, incorporating it as the primary energy storage system that's going to be responsible for our commute to work in electric vehicles. It doesn't seem like a good match. And this isn't just conjecture. Next, please. Electric vehicles actually depreciate at twice the rate as conventional vehicles, and this is largely attributed to degradation occurring at the battery pack in a similar mechanism that you would see with your iPhone. So your battery pack in your car is really degrading in the same way that you experience every day with your phone. So that's definitely something that needs to be addressed on the horizon. Next, please. Now, one proposed solution for this is a hybrid energy storage system that pairs ultracapacitors with the lithium-ion battery pack and a DC-DC converter. Some of our collaborators at the National Lab have already done full-scale studies that have shown in this configuration the reduction, you can get a 2x reduction in plug-in hybrid battery degradation in this configuration. And when you pair these devices together, you get a 52% increase in electric vehicle battery lifetime. So we can significantly extend the longevity of lithium-ion battery packs in vehicles in this configuration. And there has been some market movement to justify this. Yeah, no, you can go to the next slide. Thank you. So the device market for ultracapacitors is expected to grow from $830 million to $3.1 billion in device sales over the next 5 years. And this is driven between agreements involving the largest ultracapacitor manufacturer, Maxwell Technologies, and a variety of automotive companies. For instance, General Motors has agreed to incorporate ultracaps in their entire fleet by 2020, and Volvo has agreed to incorporate ultracapacitors in their hybrid fleet in the near future. And on the horizon, there's a great opportunity for hybrid energy storage systems featuring solid-state lithium-ion batteries, which are expected to be incorporated in vehicles in the late 2020s and early 2030s, where these batteries have a low C rate and require an ancillary high-power energy storage system to help assist them for acceleration or regenerative braking. But all of this is predicated on ultracapacitor devices getting to 3 volts. Next slide, please. So these deals are contingent upon Maxwell getting to a 3-volt device, and it's taken them quite some time to even make incremental gains. In 1997, they debuted a 2.7 volt device. It took them 17 years to get to 2.85, And in 2016, they debuted a 3-volt laboratory-based device that has yet to scale. And this has resulted in, just this past year, their stock dropping by over 60%, which is really reflecting their inability to deliver on these higher voltage systems. Next slide, please. So why is that? Why have they struggled so much to expand the voltage window? Where it really comes down to how they develop their new materials in their product line. The conventional cycle is for a team of scientists to come up with an idea for new compounds. Then they have to figure out if they can synthesize it. Once they're able to do that, they assess its stability. Then they fabricate a lot of cells because they're handmade at the benchtop scale. That results in them generating quite a bit of data, which is a bottleneck in and of itself. These cells are handmade, so some of the data is obviously thrown out. It's just not high quality data. And then from there, they're left with a report and trying to make sense of everything that happened. And this typically takes about 10 months for them to review one chemistry. Next slide, please. So what we've done is we've overhauled this process. So instead, we've partnered with chemical manufacturers that already have a portfolio of compounds at their disposal that are already in existence and don't have any scalability issues. So we use a selection algorithm to select the most viable candidates. We then put them through a proprietary evaluation process. So we have novel cells that allow us to take 16 different measurements inside of a standard unit. So these are no different than what you would see with a standard benchtop cell. The only difference is that we can garner a lot more information from that. To resolve the bottleneck associated with data collection, we actually have an automated series of scripts that fully evaluate the data without any scientists touching it whatsoever. So that expedites that process, and it generates an automated report. And this entire process, next slide, takes 8 days. So we're able to evaluate a new chemistry 8 days, and the time that it takes a typical laboratory to go through a new evaluation process, we can evaluate 37 new chemistries in that 10-month timeline. So we're leveraging this process to develop an ultracapacitor electrolyte, next slide, that operates at a substantially higher voltage and meets the requirement that these automotive manufacturers have already laid out. We're doing this with a salt that we've already developed and prototyped that reduces resistance and increases energy. We pair that with a solvent and co-solvent we're developing at Oak Ridge National Lab. It's really a mixture that's produced at scale, so it's more of an optimization process that gets us up to 3.5. And a new class of passive and active additives to help stabilize the system. This results in devices that operate at 3.5 volts, increase the amount of energy stored by 68%, and increase the power by 158%. Next slide, please. So we are targeting a price point that's actually double what the industry standard is, but you still receive the cost and size reductions that are stipulated by automotive companies. If you walk through the module level assembly, despite having a higher cell cost of 7 to 10% when you incorporate our electrolyte, you get a cost and size reduction of 15 to 20% for modules on average, because you need less cells to reach your voltage threshold. And this scales with the application. So for mild hybrids, wind curtailment, electric vehicles, and kinetic energy recovery systems, you use less and less cells. Next slide, please. And just to review the business model that makes this pretty appealing, our first step is to identify promising chemical manufacturers. We rapidly screen these chemistries, and then from there we use a contract manufacturer to package the final product and ship to the customers and handle QC issues. And the advantages of this is that it's a rapid process, so we look to scale in months and not years. It's lean, it's not very capital intensive. We don't need high overhead on the R&D front because this is mostly an automated screening process. and we don't need to build out new facilities to synthesize new chemicals. And most importantly, it's adaptable. So even though we're going after ultracapacitors to begin with, this is a blueprint for lithium-ion batteries as well. And next slide, I believe that's it. Thank you.
Okay, thank you so much. Next, we have Ralph Paul Schieferdecker of EA Systems Dresden.
Yeah, hello everyone. You can hear me?
Yes.
All right, good. Let me introduce to you first myself. My name is Ralph Paul Schieferdecker. I'm head of sales of EA Systems Dresden GmbH from Germany. I'd like to show you some model-based engineering approaches and want to introduce to you our company EA Systems. Next slide, please. EA stands for Energy Architecture, and what we do is to plan, to test, and to optimize energy supply systems in a holistic way. So our main goal is to make energy systems more efficient and to, of course, reduce carbon emissions. So we start in 2008 with a project called Residence and Mobility, where we planned a smart home, including everything like renewables, storages, energy management systems, heat pumps, and so on. And we missed a tool how that helps us to calculate and to plan and to test our energy management system. So we created this by our own, and after the first years we scaled it up from a single home to district level to heating grids. And next slide, please. So why we use model-based engineering? Next slide, please, or 2 slides, please. Of course, we can do it. We are now able to model and to simulate physically correctly or nearly correct. And we need it right now because energy systems becoming more complex, they're becoming more decentral and interconnected, and old methods like Excel sheets are not able to solve the problems we have now. So this phenomenon of digital twinning we are capable. So just let's use it. Next slide, please. We developed our own simulation software. It's based on Simulation X. It's a Modelica-based open source software. It's a multi-physical software, and as I said, we have a holistic approach. So there are many specialized tools who can simulate or model electric grids or HVAC systems, but this is not our way. We are trying to combine all the things that comes together in energy systems like power, heat, cool, the whole environment, user behavior, load profiles, and so on. And for that reason, we developed this tool. So to make easy decision making for, of course, feasibility studies or dimensioning questions, but mostly also for cost and revenue. And next slide, please. The library Green City has a lots of modules, more than 300, including buildings, energy producers, consumers, load profiles, connectors, pipes, cables, everything that's inside a house or in a district that has to do with electricity or heating or cooling. And next slide, please. With this models, we can, first of all, we can make a digital twin to copy the reality as exact as possible, or to make layout studies to do it from scratch. And this has some advantages, like to prove business models, to evaluate them, or to test control systems for charging controllers or energy management controllers. So for that we use it. Next slide, please. Or two. So we are not just software developers. Most of the time we use our own software for our engineering and the consulting. So this is a normal project of us. An investor wants to design an integrated energy supply concept, make some feasibility studies and energy and cost evaluation, how to supply this district with heat, with electricity, and also to charge the e-vehicles that will come in the next years. So, and we calculate some variance for them, and they decide what they want to do. Next slide, please. So in a larger scale, we do it now for in a smart city project in our hometown Dresden. It's a Horizon 2020 call, and we modeling and simulating a whole district and all the measures that will take place in the next 5 years. It's mostly residential buildings and schools. We are simulating a district storage for and its control strategies to deliver power to the charging infrastructure and to save electricity from the PVs that will be installed. Yeah, next slide, please. The same with heating grids. This is a example for an optimization of a heating grid. We had some demographic changes. Lots of people left this city, and so we made a model, thermal model of the heating grid, and calculate the energy efficiency potential that they are in the grid when we, for example, reduce the temperature of this grid. Next slide, please. Also, it's also a heating grid, and this is a winter sport village in Germany where we have 2 million euros just for running costs, just for the cooling of the buildings, the bobsleigh run or the skiing hall a year, and they want to bring the waste heat from this facilities to the village, to the heating grid there. And the concept for this, we modeled this, we're simulating it, and now it's becoming realized. And we will see in 2022 we have a sports cup there, and then it will be way more efficient than today. Next slide, please. The electromobility is, in our eyes, will be or needs a lot of high power charging infrastructure in the next years. And also for this project, we are simulating how to integrate renewable energies, how to reduce the costs for e.g. Grid expansions, or we calculate the size of storages, the kind of storages or control strategies we need if we have a lot of e-vehicles that charge inside cities in the local grid. And that's the point we also do. Next slide, please. So same here for virtual power plants. We use models to give some options for the operators based on our simulation models. Next slide, please. And for all the software developers, this is we have a some services and testing platforms for automation systems like smart homes or smart grids that we can, inside a software in the loop test their control drafts against our building models or district models, and yeah, that shorten the development cycles, and you can find out early some defects in the algorithms. And yeah, so these are some examples what we're doing. Next slide, please. We are now 10 years old. We have some nice partners, and we are growing. And that's it from my side. Thank you very much.
Thank you so much. Now we will be moving on to our next presenter, Antonio Aichetti from Rebus Tech. Welcome, Antonio. Okay, it looks like we're having a little bit of technical difficulty, so we're going to move to the next presentation. Let's see here. Jeroen Olde Dobelink with Bruco Integrated Circuits.
Hello, everybody. Can you hear me?
Yes, we can.
Okay, thank you. Well, my name is Jeroen Olde Dobelink. I'm an analog ASIC design engineer for Bruco Integrated Circuits. So please, can I have the first slide? I'm not. Yes, there we are. So I want to start to introduce our company. So what we are, an independent, privately owned fabless IC design center, and we do both analog and mixed signal design. We offer design services, but we can also offer complete turnkey solutions from ID to products. Our major customers are customers in the semiconductor area and also in the non-semiconductor area. Some of them are the real big companies in the semiconductor. We have about 50 people, and most of our people are highly skilled engineers. So please, next slide. I still see the same slide. Okay, thank you. So as I said, we can start from scratch, from an ID, and work it out into a specification of a product. And that's one thing. So that the IC is the end product, but we can also deliver ICs. We can store them and deliver them. We can store wafers and deliver ICs on customer demand. And we also have in-house, we have capability of monitoring design flows. There are specialists who in this area too. Okay, thank you. Next slide. So, well, then let me explain what our expertise areas are. So one of our areas is RF technology. We do several projects for cell phones, for satellite receivers. We also do power amplifiers for the base stations. We do satellite communication, Zigbee radio, WiMAX, amplifiers and mixers. But we also do, for instance, smart magnetron solutions, where we use power transistors instead of magnetron tubes. Okay, please, next slide. Well, this is Internet of Things is of course a very important area in which a lot of products and activities are in this moment. How to connect everything together. So there, of course, there's not a lot of RF technology is needed, and we are operating in this market as well. So please, next slide. Well, another expert area is in industrial. We do several different things in this area, like well, you see the example of a Fluke handheld scope meter. We do optical maskless lithography, lamp drivers, earth fault circuit breaker. That's just some examples of products. Power converters in many different power levels and voltage ranges. LED drivers, LED lamp drivers. Please, next slide. Well, also in the automotive area, we have expertise already for a long time. It's actually the area in which our company started. So there's a lot of electronics inside a car today, different things like communication, but also in the power range. There is a lot of equipment. ICs are involved. Also, for instance, the Class D amplifiers, audio amplifiers, is also one of the things we have been working on. LiDAR, resonant mirror drivers, is also one of the things we have been developing. Please, next slide. Well, switch mode power supplies is that's really one of our expertise areas. So we have designed line adapters, which go from AC to DC. We also have electronic variacs, which convert AC to AC. Of course, we have also made several DC to DC converters. And the application area is home, industrial lighting, motor drivers, and as I already mentioned, Class D audio amplifiers. Please, next slide. Well, this is now there are some slides which show practical examples. Well, this is industrial lighting control chip which goes up to 100 watts and operates from the mains 230 volts. It can the controller can operate in the flyback mode, in LLC mode, or in buck mode, depending on the requirement. Please, next slide. Another example, this is a multi-phase buck converter at the 100 watt level, which makes 3.3 volts from 5 volt. It was used for the Pentium processor at the time. Okay, next slide. Well, we also made power management unit chip, which is used in the media players to deliver all kinds of supplies in terms of voltages, current levels, power levels, and these can be both switch mode converters as well as LDOs. So in these PMU, we have buck converters, boost converters, and LDOs. So please, next slide. Well, this is an example of a very small power converter from mains to low voltage DC, and at 5 watt level, which fits into a plug. Okay, next slide. Well, this is an LED dimmer, which is which operates as an electronic variac. So it's not a phase cut dimmer. Well, phase cut dimmer is of course the most common. You have leading edge for the older dimmers for incandescent lighting. The newer dimmers you mostly have trailing edge technology, but well, this one is using is an electronic variac, so it keeps the sine wave in shape, and it controls the amplitude, and a lot of lamps operate very well on such a dimmer, even non-dimmable lamps. Okay, next slide. I think we are done. Yes, these. I just want to say that these examples are just an excerpt of many other projects which we have been doing here. So, well, if you are interested in further in who we are as a company, what we can do, and maybe we can do something in cooperation, please contact us. This slide shows the contact data.
Terrific.
Well, then, thank you very much.
Thank you so much, Jeroen.
Okay.
Antonio, Ketty, if you're on, we'd like to go back to your presentation. Are you on?
It's Paulo here. I had a contact with Antonio, and he has problem with the firewall and with the software. He's
okay. All right. Well, we will
going to restart the system with a different network. Let's wait for a while.
All right. For now, we'll move on to Graham Hauser of Lux Semiconductors.
Okay. Thank you, Beth. Hello, everyone. As Beth said, my name is Graham Hauser. And I'm with Lux Semiconductors. We're an advanced materials startup company working to create a platform for next generation electronics. Next, please. So our company is myself operating as CTO and the inventor of our original technology, Shane McMahon, who's also functioning as CEO. We have a host of advisors from our background in academics and the various incubator programs that we've been involved with. We are both recent graduates of the PhD program in nanoscale engineering here in Albany, New York. And to date, we have received funding from the National Science Foundation, Nexus New York program, which is an incubator in this region, and the Department of Energy sponsored program at the Oak Ridge National Lab called Innovation Crossroads. Next, please. Okay, so most people are familiar with the role of the silicon wafer in integrated circuits and all of our devices today, all of our smart devices, but there is a growing number of applications. Next, please. In very quickly emerging and growing markets that don't quite require the perfect silicon wafer and can benefit from thin film semiconductors that can offer lower cost with still reasonable performance and also additional features such as flexibility and large area and manufacturing and high throughput processes as enabled by thin film. So some of these markets include the Internet of Things, which is just expanding exponentially. IoT nodes are expected to start appearing in all of our products. Next is low-cost sensors. Sensors is also very rapidly growing. And then efficient lighting panels and efficient displays such as OLED displays. So next, please. If we look at OLED displays as an example, in this case, a mobile OLED, what we start with is a thin film semiconductor. So for LCDs, this would be an amorphous silicon. For OLEDs, this is nowadays typically a recrystallized silicon thin film onto which thin film transistors are fabricated in an array. This backplane array then has the OLED material, and for a mobile phone, you can add touch panel and cover glass as well. But our company is focused on the thin film semiconductor portion onto which the semiconductor material onto which the thin film transistor arrays are fabricated. And out of the relatively large and rapidly growing OLED market, this TFT backplane array accounts for a small percentage, but still a decent portion. Next, please. And so when designers are considering the semiconductor material, thin film material, for these TFT backplanes, ideally what they would want is high mobility. So this is electron mobility, which largely dictates the performance and characteristics of the device that they can create, while in addition, ideally looking for low cost and more so these days, a thin and flexible form factor. So unfortunately with today's options they're typically presented with a pick two scenario, in which case you can only have two of the three. So the silicon wafer is the top in terms of mobility when dealing with silicon, at least. In terms of dollar per meter squared, it's not exactly low cost, and it's certainly not thin and flexible. So if we're looking at the low cost thin version, that's amorphous silicon, and we have some other amorphous semiconductors. And then if we want a high mobility and thin flexible format, then we can look at recrystallized thin films. And so it's this portion, recrystallized thin films, that Lux is targeting. If we go next. The state of the art currently for production of recrystallized silicon thin films for OLEDs is using an excimer laser based process to create what's called low temperature polysilicon. The drawback here is that this equipment is both large and highly capital intensive, sometimes requiring raster scanning of these lasers, especially for the larger generation size glass panels. Next, please. So Lux's innovation is a new method for recrystallizing semiconductors. We are focusing on silicon, but we are also experimenting with germanium, which has even higher electron mobility. And our process is different in that we start with an ultra thin metal foil. We deposit a series of interlayers for diffusion barrier and electrical isolation. Then we deposit amorphous silicon, and through our not yet disclosed process, we then recrystallize the silicon into highly crystalline silicon films. And so we are still seeking, we have filed for patent protection on this process. We expect to receive it. And some of the benefits compared to the laser process is that we don't require raster scanning. It's a full width, so highly scalable to any size panel or roll, and we can achieve high throughput. So in 2017, we received funding from Nexus New York to build a prototype chamber to test this, and we've been developing materials since. Next, please. And so currently we're on 1.5 inch wide strips for recrystallization. This is at the proof of concept prototyping phase, with the end goal, as I mentioned before, being scalable towards much larger area roll-to-roll or sheet-to-sheet systems that will be compatible with the large panel manufacturing in the TV industry. Next, please. So we actually spent the last half of this year really searching for our target markets. So what a higher mobility compared to LTPS affords is it allows for higher pixel density, so smaller TFT pixels and lower power. And where we tried to find is customers that could really benefit from this. And we've landed so far as a beachhead market in virtual reality, where an industry that is really searching for higher pixel density with lower power, and designers would also preferably like some flexibility in these displays. Next, please. Next slide, please. Okay, so we see ourselves as being a material. Oh, okay, that's fine. So here's a little timeline of our company. We were founded roughly 2 years ago. We fabricated a custom-built prototype chamber. Since then, we have received funding from the Department of Energy and the National Science Foundation. And next, please. And so that brings us today where we're really working on material development, trying to really improve our crystal grain size, which largely dictates the electron mobility of our films. Through next year, we will be beginning to test transistor fabrication, and following that, we will be working with some of our early partners for device level testing. Next, please. Concurrently, we're also seeking additional funding. We have some outstanding grants, one with the New York State Energy Research Development Agency here in New York, for which we would use to fabricate a larger roll-to-roll recrystallization system using our technology. We will also be seeking a second phase of our National Science Foundation grant, and looking into the future, we will start to seek out larger scales or design larger scale systems to test our recrystallization system. Next, please. I believe that's it. So I'd like to thank you all for your attention, and you can see my contact information on this slide.
Terrific. Thank you so much, Graham. We're going to be moving on now to our next presenter, Bill Acker of New York Best.
Hello, I'm Bill Acker, the Executive Director of New York Best. If you can move to the next slide. New York Best is a member-driven organization advancing the energy storage industry, both in New York State and globally. We are working with many companies and institutions to bring energy storage products to market. Our members include startup companies to some of the world's largest energy companies, both here in New York and around the world. We presently have about 160 member organizations, mostly companies, some universities, and others involved. We achieve this mission by communicating information and facilitating connections, running conferences, connecting people, providing information to the community, accelerating commercialization through a variety of means I'll talk about in this presentation. Educating policymakers and stakeholders to make sure that the market rules are correct and that proper programs are in place, and particularly in the electricity industry, proper tariffs are in place to allow for the industry to grow. And promoting New York's intellectual and manufacturing capabilities, connecting companies to those and helping companies do economic expansion in the state. We also work directly with many companies in order to put projects in and ensure that the energy storage is being deployed effectively. If you can move to the next slide, please. Our activities that support particular company growth and project deployment. We do a lot of work directly technically assisting companies through our partnership with NYSERDA, the State Energy Research and Development Authority. We also partner with New York State Economic Development Arm to help companies who are interested in siting facilities in the state or doing business in the state. And we operate what we call a bridge program, which is a program that provides assistance, particularly to startup companies, to help companies emerging from universities or other startups with deep sector expertise in the energy storage space. If you move to the next slide, please. We provide a lot of services to membership. These include a bi-weekly newsletter, spotlights on members. I want to spend a second on the supply chain database. We have a resource that we put in place to connect companies throughout the supply chain in New York State. We work collaboratively also with many other New York State organizations like FuzeHub to make sure that companies are connected to both manufacturing facilities and all the areas of the supply chain, and also to potential customers and to potential technology developers. We also do a substantial amount of work in the area of policy. As you may be aware, New York State is one of the leading states in the United States with regard to renewable energy, with a goal of 50% renewable energy by 2030, so in 12, 11 years from now. And also a goal with energy storage on the grid of 1,500 megawatts by 2025, and likely a goal of 3,000 megawatts by 2030. We're working with the state to bring out new market rules to enable that grid deployment of energy storage. Next slide, please. We also work with partners to provide a great deal of resources to companies in the space. These resources include a testing and commercialization facility in Rochester, New York. That facility is operated for us by DNVGL. It provides testing on energy storage devices. These are actually all kinds of devices in addition to these batteries. But particularly testing all the way a range of size from cells to modules to full systems, including safety testing, including the new UL 9540A, which is a burn test to make sure that the batteries systems don't propagate in a fire case. We also partner with RIT and have a battery prototyping center. So if people have a new chemistry or new materials for energy storage devices, they can prototype them in commercial format batteries. With Kodak, Kodak has developed a battery pilot manufacturing facility that's a multi-user facility to make different scales, sizes of batteries in volume. Next slide, please. I mentioned the networking part of our organization's activities. We do a number of conferences each year, and we participate in quite a few events along with many of our members, particularly 3 conference areas I'd like to highlight. In March each year, we hold a conference called Capture the Energy, which is generally the largest East Coast conference for energy storage, and it's held in Albany, New York. Focuses on the energy storage industry. We hold a technology conference in the fall that moves around the state, and that focuses on technology, as the name implies. And then we also hold an investment conference in Manhattan each year, where we cultivate a group of startup companies and bring them in front of qualified investors to achieve financing for those companies. Next slide. I think this is going to wrap us up. So that's a quick overview of New York Best. We'd be happy to engage with any of you who, particularly if you're interested in energy storage, or if you're interested in renewables and touch upon storage. We'd be happy to work with you. You can learn more information at our website listed here, or reach out to us. So thank you for your time today, and I'll turn it back over.
Thank you so much, Bill. I just want to do one more check-in to see if our panelist Antonio Ichetti is with us. If so, we can backtrack to your presentation.
Yes, can you hear me now?
Okay, for our listeners, just bear with me as I backtrack a little bit here, and then we will go ahead with your presentation in just a moment.
Yes, thank you. Sorry for the problem.
It's no problem at all. Okay, here we go.
Okay, thanks. Thank you for waiting for me. My name is Antonio Ichetti. I'm the co-founder of Rebus Tech, which is a startup born in Italy to develop new techniques for the making of photovoltaics devices. Next slide, please. So amongst photovoltaic technology, we differentiate from standard silicon panel, or let's say standard business for photovoltaics, because we decided not to target the general electricity need, but we focus on the need posed by portable energy. So the availability of having energy on board on electronic devices. So there are so many applications where electronic devices are used, and they need to be independent. Examples, concrete real examples are like home automation, industrial automation, beacons, and application and similar application. But these are just part of these growing trends of some very well-known IoT, where more and more devices are expected to be able to collect data, to interact amongst them, and to share the information and adapt their functioning. So these these devices are based on wireless technology for the communications, but to allow for power supply, the independence is guaranteed by batteries. Of course, battery is a very well known and established technology, but they have some they pose a drawback, which is a limited time on the lifetime of the devices, which is based on the limited amount of energy carried by batteries. Next slide. So batteries are not the only solution. Another possibility is to make energy harvesting, and photovoltaic is very useful for such application. Let's say in standard, even in indoor ambience where the light intensity is lower, of course, than direct sunlight, but even in indoor situation, usually the light is the vector of the most intense source of energy. So the technology, the reason we believe our technology is very useful for this application is because our devices are quite different than standard. They are printed on plastic substrates, which means they are flexible, which also means conformable, not also on uneven surfaces, adaptable to the surfaces. They are printed, so this means that their shape can be customized upon clients' requests. They are made of plastic. They are quite easy to be integrated into electronic devices. Next slide. So this is interesting new technologies, which is amongst the so-called third generation photovoltaics, which is based on two pillars. On one side, we have these organic material, these plastic materials that have the interesting properties of having not as insulator but as conductor and semiconductor. So with plastic material, we can use plastic materials to make electronic devices, but the main advantage is the fact that these materials can be dissolved into solvents and forming inks. And when we have inks, these allow to the second pillar, which is printing. So the technique we use to make this device is actually the same printing technique derived from graphic arts technology. Next slide. And these two pillars also reflects a bit the story of Rebus Tech, which is, as I said, a startup coming from the Italian Institute of Technology, which is a research center based in Milan, where we had this experience on these materials. And then we met Automotive, which is an Italian company making roll-to-roll printing lines, like the one you see in the picture, which is, and these are the two founders of the company, and also Automotive, the provider of the technology we need for making solar cells. So if you think at the process we use, think at the same printing tools that you see in picture, where every printing heads, there are multiple printing heads, and each one is devoted to the printing of one layer. And by composing these layers, we can make a full solar cell on a plastic substrate. Next slide. This process allows then the properties I showed you about this panel, and we believe that these flexible photovoltaic films are very useful for electronics, because basically we can use them as let's say a second skin and cover the surface of these electronic devices, transforming this available surface on their case into an active surface that can convert the light, and as I said, also indoor light, into the power and that the devices need to run. And this can allow either longer lifespan, but also more functionality, so more capabilities on the electronics on board. Next slide. So the way we work, and these are some of the partners we have been working with, and we made some samples together. We do business to business, so we provide them with our solar panel that we make, and usually we follow these stages. We start from the feasibility and the design of the solar cell on custom requirements. Then we study the feasibility, which also means calculating the light intensity, which converts to the amount of energy per area that we can provide. Then we start prototyping in order to test these materials on real application, and then before going toward production. Amongst these companies, we have reached both the prototyping and the production phase. Next slide. Some example of this activity we made is these devices we made together with STMicroelectronics, which is basically a smartwatch. So it's an evaluation board where they put several sensors on this watch, and they need to power them. So they asked us for these 3 panels you see in picture, and we were capable to use both the central part of the watch, but also the wristband, because of the flexibility of our techniques. Next slide. This is an application. The first one was an application that also works in indoor. A second one is an application that works in outdoor, where of course we have more light intensity. And this was a project made with another company named Aussie, where they make devices for the monitoring of cathodic degradation into pipelines, and they need to gather information and communicate them. They actually use a narrowband IoT communication, and they asked us to cover all these their sensor with our panel in order to make these devices autonomous and not having to go to each sensors in order to charge the batteries or substitute them. Next slide. So these are the example of application we make. As you see, we are all working with on a B2B approach. So we provide panels and company. This last slide is overview of the management of the startup. As I told you, the main partners and the shareholders are both OMED and the IIT. And we have this solid background made by this the engineer founded this company. Thank you for the attention. Next slide, and that's the last one. Thank you.
Okay, thank you so much, Antonio. I'm going to move ahead to the next phase of our presentation now. Let's see here. Okay, this webinar and slide presentation will be available tomorrow at the following URL, fuzehub.com/webinarb2b/energy-systems. On the FuzeHub website, you may also want to view past webinars focused on autonomous operations, smart cities, and health applications of advanced electronics. We hope you've heard things that will cause you to initiate a connection to one of the presenters or companies we featured on this webinar. They stand ready to assist you in getting engaged. Companies can also contact FuzeHub directly at fuzehub.com, where you can fill out an easy form and one of our manufacturing specialists will call you within 2 days. Again, FuzeHub is here as a not-for-profit to help companies navigate New York's robust network of industry experts at institutes, universities, and throughout our network of manufacturing extension partnership centers. We'll now begin the Q&A session of the presentation. Your submitted questions will be addressed by the presenters. So the presenters can all unmute yourselves and chime in as you like. The first question we have are, what are one or two of the greatest challenges associated with more efficient energy integration? Anyone want to chime in on that one? All right, I will go to the next question. Using today's smart grid sustainable technologies and smart cities platforms, how much energy savings can be realized and how long would it take to break even?
That's a quite difficult question because it depends on the measures you gonna do, and very hard to say.
Well, in terms, this is EA Systems.
Yes.
Well, in terms of some of your studies, maybe on a much like that ski area, the winter park there that you mentioned as one of your case studies. Have you done an assessment utilizing the wood chip boiler system and the control systems and storage network that you're envisioning? Have you done any kind of assessment of what kind of energy savings you might realize versus using a conventional, non-smart conventional grid?
For this example, there's no grid existing right now, and
so you're starting from scratch.
Yeah, yes, that's true. Or not we. It's the scratch. Someone else. So they came to us to simulate it and to model it. If their ideas are capable to realize, is it to do a feasibility study, and but mostly when we are doing variant analysis of energy supply systems, there's a big gap between energy efficiency and cost efficiency. So the investors are if it's matching, if you can save costs and reduce your energy consumption, it's good. But most of the time, it's if it's no business case, energy efficiency is not so interesting for most of our clients. That's part of the truth now.
Sure.
Great. Well, we have one more question for New York Best. Can small companies benefit from connection with New York Best, and what is the best way to get connected with all the news and events that you had mentioned?
Certainly, small companies can benefit greatly. We have a lot of programs for small companies, and we have reduced membership. It's only $500 for a small company to be part of New York Best for a year. And the best way is actually just to go on our website and take a look, and you can actually sign up there. You also can sign up for our newsletter there, and you certainly can reach out to us with the info at newyorkbest.org email that we put up there as well. We offer a lot of sessions at the various conferences that promote and connect small companies, and also all the resource assistances for commercialization is usually highly beneficial for small companies.
Terrific. Thank you so much. In closing, thank you for attending this webinar, and stay tuned for future FuzeHub webinars and program opportunities. And thank you for joining us today. And we'll look forward to future webinars with you. Have a good day.
Okay, thank you.
Thank you.
Thank you.
Thank you.